There we go. To being recorded here. Hold on. Got it. Okay. Excellent. All right. Hi, everyone. So my name is Rebecca Charbonneau. I am a historian of science. I did my PhD in history and philosophy of science at the University of Cambridge. That was followed actually by a postdoc where you currently are at the Center for Astrophysics, not at the Black Hole Initiative, but at the Woolbach Library. And I'm currently a Jansky Fellow at the National Radio Astronomy Observatory. It's quite a fun position because I'm actually the first ever humanities Jansky Fellow. It's a position that's normally given to astronomers and physicists. So it's quite exciting to kind of start being the person to push forward the value of historical studies within scientific institutions. And that's something that I'm hoping to cement for you today. My talk today is going to be on the first VLBI experiment between the US and USSR. Hopefully by telling this history, I'll give you a glimpse into some of the challenges of international scientific cooperation in times of war and conflict, something that unfortunately seems to be more relevant now than ever. All right, let's see, how do I move forward my slides? There we go. Okay. So first, I'll begin by telling you a little bit about my work and what I focus on. So I'm a historian of radio astronomy, primarily during the Cold War period, mostly the 60s and 70s. One of the things that interests me the most is looking at how scientists cooperate with one another, even in geopolitically hostile situations. This was, of course, particularly relevant of a research question for the Cold War period, when scientific technical competition was, arguably at its peak. And I was really curious to figure out what exactly drove scientific cooperation, even when there wasn't necessarily an incentive to cooperate with one's international peers from nations that were hostile to one another. And it turned out, as I was doing my research into the history of radio astronomy, that the development of very long baseline interferometry was one of the most interesting and relevant fields of study to look at, because of course, as I'm sure all of you know, at the Black Hole Initiative, VLBI, it kind of necessitates international cooperation just by fact of the matter that its requirements, its technical requirements, requires telescopes on different parts of the world, optimally in different continents. And so if one wants to study science that requires international cooperation, VLBI is an excellent field to look at. And so that was what I started studying when I was at Cambridge doing my PhD. And during this time, in about 2019, I actually had an opportunity to go to Moscow in Russia for the Radio Astron International Scientific Council meeting, which was a group of astronomers and physicists from largely Australia, the UK, the US, and Russia, who had cooperated on Radio Astron, which was a space interferometer that was recently decommissioned back in 2019. In fact, this meeting was the last Radio Astron meeting. I actually was there on the 62nd anniversary of Sputnik's launch. So you can actually, there's a picture of me there, kind of underneath this model of Sputnik in the Astrospace Center of the Russian Space Research Institute. So I was really quite excited to be there. And I spent most of my time interviewing, doing oral history interviews with the various pioneers of VLBI and space VLBI who were at this meeting in Moscow. And one of the people I interviewed was Dave Jauncey. He's an Australian astronomer. I'm sure quite a few of you may know him. He did a lot of the early VLBI experiments, both in the US and in Australia. And I asked him about his experiences doing these international projects in the 1960s and 70s. And he had a lot of very positive recollections of these early experiments. He told me that one of the major strengths of an area like radio astronomy, and in particular VLBI, is that you don't just deal with your own country. He says you're literally dealing with the world. He said the Cold War was going on, but the scientists were still collaborating. These things are separate from politics, he told me, and he thought that was a very powerful phenomena. This was, of course, very beautiful. This scientific internationalism that Dave was speaking about. But I do remember it striking me a little bit funny because Dave was telling me all about the apoliticism of astronomy, particularly radio astronomy. And he was telling me this from Moscow on the anniversary of Sputnik's launch, one of the most politically charged scientific events in history. And I found it a little bit contradictory. And this contradiction became even more obvious as I spoke to some of the former Soviet scientists who were in attendance at this meeting. In particular, for example, Leonid Gurvits, who is a former Soviet astronomer, who's a pioneer in space VLBI. He told me, that he really valued his colleagues and his friends. He formed a lot of important relationships during his work, his international work on VLBI. But he said, when our colleagues tell us, our American colleagues tell us, it was so friendly and lovely and apolitical, he believed that they didn't fully appreciate the political cost, the challenges involved in conducting some of these early experiments. He says that they can hardly imagine. It was very, very difficult, especially from the side of the Soviet Union. And so here I have these two juxtaposed positions, one arguing that science was apolitical, above politics, and that it was driven by this pure scientific motivation. And on the other hand, we have, in some ways, this very obvious impact of politics and challenges that faced the science and the scientific experiments because of the geopolitical hostilities. And so this is a tension that's really important to pay attention to because it's something that's becoming even more relevant today. In the 1960s, kind of at the height of globalization, the beginning of globalization, international cooperation within the sciences was becoming more common, but it's even more so today. Pretty much all major astronomical projects today have at least some degree of international cooperation. If you look at many of the major ground-based astronomy projects, for example, the Atacama Large Millimeter Array, that's operated jointly by Japan, the European Union through ESO, and the US through NRAO. And that's an incredibly international project. It also has partners like Taiwan. And then, of course, like the Square Kilometer Array, which has an incredibly large group of international partners. And we can already see it playing out, and it probably will continue to play out in the future, that many aspects of human politics will affect these projects or are already affecting these projects. For example, the legacy of colonialism in Africa affects European participation in SKA, which is siting its telescopes in South Africa and Western Australia. Taiwan's role, for example, in ALMA may affect Japan, Europe, and US relations with China. And so it's really impossible to ignore the political element of conducting scientific experiments internationally. And this is maybe even more obvious just through looking at the news. There's a recent challenge in the scientific community about how to handle relations with Russia ever since Russia invaded Ukraine earlier this year. It's one of the first ground wars in Europe in decades, human rights travesty, and it leaves a really uncomfortable challenge for scientists in how they decide to partner with their Russian colleagues, many of whom they have longstanding relationships with. The response from the scientific community to the Russian invasion of Ukraine has been somewhat spotty. There have been many disrupted or canceled programs, including things like OneWeb, eRosita, an X-ray telescope, ExoMars, and others. Russian scientists have been banned from attending certain conferences. They've had their funding pulled. Sometimes barred. There have been calls to bar Russian scientists from publishing in scientific journals. But at the same time, there's also been, again, this call for internationalist science. It's a very powerful myth in science. Yuko Harayama, who is a co-chair of the Japanese Association for the Advancement of Science, recently said, and this is a quote, "My view is that we have to protect and defend science anywhere without distinction and borders," right? The idea that science is, again, internationalist and should be apolitical. But of course, others disagree. There was a call from other scientists in different groups that called that sentiment naive, arguing that pretty much any top scientist or scientific institution in Russia will have connections to the Kremlin. You can't get power or influence without ties to the regime, and therefore any cooperation is support for the invasion. So again, there's just this really muddled response to this conflict. And this shouldn't be too surprising because this tension between internationalism and competition and war is something that we have seen throughout the long history of the space sciences. There is this tension between thinking about space as very mythological, very peaceful, right? We have kind of the beautiful moment of the Apollo-Soyuz handshake. Vladimir Putin even recently said, as recently as 2012, that despite whatever difficulties we face on Earth, that people in space work shoulder to shoulder, not just for countries but for all of humanity. Again, kind of evoking Harayama's sentiment that science is without borders, and space, which inherently doesn't have borders, is even more apolitical. But then, of course, there are the very obvious contradictions to this, which is that space is incredibly political, right? The early space race used V2 rocketry, the remnant of war. We have one of the motivations for developing rocketry equipment was for improving the capabilities of intercontinental ballistic missiles. Space is increasingly militarized. And even astronomy outside of a military context still wrestles with the remnants of that nationalist competition rhetoric. The 2020 Decadal Review I found particularly interesting because it was incredibly rife with this nationalistic rhetoric of the US falling behind or not being number one on the global stage in astronomy. And so there is, again, this tension. So what I want to do now for the rest of the talk is talk about this history of astronomy and war and see how that affects the internationalist rhetoric of scientists cooperating. And to do that, I'm going to briefly recount the history of war and radio astronomy. So radio astronomy has a really rich connection to warfare. And it begins in World War II with the development of radar equipment. So the first operational radar system was developed by a man named Robert Watson Watt between the periods of 1935 and 1938, right as the UK was on the cusp of war with Germany. Watt's work was supported by the British Air Ministry because of a recognition that Britain was vulnerable to the growing threat of an air attack by the German Luftwaffe. And as the war expanded across the world, most of the countries involved, especially the UK, Germany, the Netherlands, Australia, the United States, the Soviet Union, and Japan, note that those countries with radar systems are also the countries that are the most dominant in radio astronomy today, not a coincidence. So these countries had all developed radar systems during this time. And interestingly, these nations recruited physicists and radio engineers, often from universities, in an early example of what's commonly known now as the military-industrial complex, which was a phrase termed by US President Eisenhower in 1961. Because many of these military systems developers were trained as academic scientists or engineers in a university context, they sometimes had a hard time letting go of their academic roots and made serendipitous scientific discoveries related to their military activities and with the new tools and equipment they were using as military officers. One of the most prominent examples of this would be the observations of James Stanley Hay, who was a British physicist who joined the British Army Operational Research Group, the AORG, which was trying to improve the capabilities of anti-aircraft radar systems. So what that means is basically because of the efficacy of radar as a defense system, it was really, really good at detecting radar and enemy attacks, countries would try to jam their enemies' radar systems. In other words, they would send out radio signals that interfered with radar systems by flooding them with noise or other false information. So the AORG wanted to study both how to conduct and to fend off radar jamming. And Hay was in charge of this. So in February of 1942, he discovered that there were 10 radar systems that were being jammed by overwhelming noise interference in the 55 to 85 megahertz range. And Hay noticed that this interference, this jamming, came almost continuously and exclusively between dawn and sunset. In other words, when the sun was up. And because of this, he realized that essentially it did not appear possible to arrive at any other conclusion that the interference was associated with the sun and the recent occurrence of sunspots that had been observed in another observatory in Britain. And so as the war came to a close, Hay published his findings about the radio emissions from the sun that were interfering with the radar systems in Nature. And this is one of the earliest examples of military radar operators transitioning into radio astronomy researchers in the post-war period. Another example you can see here on the left is Sir Bernard Lovell. Lovell was a physicist working in cosmic ray research at the University of Manchester. At the start of the war in 1939, he joined the Telecommunication Research Establishment to conduct research into H2S radar systems. While investigating and working on these radar systems, he noticed background echoes, which he thought might be caused by cosmic ray showers, which was something he had been interested in while working at the University of Manchester as a physicist. So at the end of the war in 1945, when he returned to Manchester, he actually was able to take much of the ex-military radar equipment with him to continue his studies into cosmic rays. He eventually ended up discovering that they were not actually cosmic rays, but what he was detecting were radio signals from meteors, which had been ionizing small parts of the atmosphere during their descent. And this was what was being detected by the radar. And so this detection in 1945 by Lovell of meteors was actually the start of one of the world's earliest and most distinguished radio astronomy observatories at Britain's Jodrell Bank Observatory. And now what's most important here is that Bernard Lovell's discovery and the launch of Jodrell Bank Observatory meant that he was very invested in building radio telescopes, right? He initially built a 66-meter telescope, which was actually used by another British radar technician turned scientist to discover radio waves coming from the Andromeda Galaxy, one of the first instances of extragalactic radio astronomy. And then he eventually was able to procure funds to build a 76-meter steerable dish, which is now known as the Lovell Telescope, a very famous telescope in Britain. And it was funded by both the University of Manchester and the UK government. However, his ambition led the initially 259,000 pound telescope. That was the budget. He ran it approximately 381,000 pounds over budget, so more than double the initial budget cost. And this left the university and the government to cover the costs. Because of this mismanagement and arguably fraud, he actually faced an inquiry from the British Public Accounts Committee, which might have resulted in his imprisonment. But fortunately for him, right around this time in 1957, Sputnik launched, and as it turned out, there was no facility in the West that was capable of tracking Sputnik's rocket. And so they used the Lovell telescope. Both the US and the UK collaborated in order to track Sputnik's rocket. Now, the reason they were interested in tracking the rocket specifically is because a rocket that can go into orbit is essentially an ICBM, and the West quickly realized that it was going to be incredibly important to be able to track these rockets for defense purposes, and this transformed the potential for radio astronomy facilities to serve not only as scientific establishments, but also military ones. And we can see this in a number of different ways. It's not simply for space tracking, but also for intelligence gathering. At my workplace, the National Radio Astronomy Observatory, it was established in 1956, so right around this same time. And one of the things that the US government did to support the establishment of a radio astronomy facility was to create a national radio quiet zone. So this was a period of about a space of about 13,000 square miles, where there was really incredibly reduced radio capabilities in this area. And this was kind of publicly announced for the support of radio astronomy, but indeed 30 miles away from NRAO's site in Green Bank, West Virginia, the Department of Navy built a naval intelligence facility, and that was also being supported by the National Radio Quiet Zone. So again, we have this dual purpose: radio telescopes for space tracking, radio telescopes for intelligence gathering, and of course, science. And so now I'll tell you about the first USSR VLBI experiment and how it was impacted by this burgeoning new nature of radio astronomy, both as a scientific pursuit, but also one that was incredibly useful for military purposes in the Cold War period. So in the 1960s and 70s, NRAO had a newsletter called The Observer. It's quite the document. It is a collection of news articles about science happening at the observatory, announcements from family members, births, engagements, also a lot of cartoons drawn by scientists. It's a really fantastic primary source for historians, and it includes quite a lot, especially in the period of the 1960s and 70s, on the development of the LBI. You may not be able to see the details of this, so I'll read part of it. This is a cartoon that was included in the Observer, I believe in 1971, called The Game of VLBI. So it's talking about some of the early attempts at developing VLBI at NRAO. And you can see things like towards the end, it says, lo and behold, a consistent model for the source is found, but it appears to be contracting at 10 times the speed of light. Kellerman doesn't believe you, back 3, and it culminates in your paper being accepted for publication. And so the Observer is a very glib, somewhat satirical attempt at documenting the early scientific experiments at NRAO in this period. And one article that appeared in the Observer in 1969 and 1970 was how not to do a VLBI experiment. And just because I am so excited about it, I will share the PDF in the chat at the end of my talk, because I think everyone should read it, and I'm not going to have a chance to fully go through it in the brief time we have here. But essentially, in 1968, the US, specifically astronomers at NRAO, were some of the pioneers in developing VLBI as a technique. And one of the things they were trying to do were to expand their baselines as far as possible to see what the limits of conducting VLBI were. And so after a successful experiment with Sweden in 1967, astronomers at NRAO wanted to see what the farthest possible baselines they could get were. And as it turned out, the furthest possible baselines they could have with short centimeter wavelengths was in the Soviet Union. And so in 1968, Ken Kellerman and colleagues at NRAO sent a letter to the Soviet Union to ask them if they'd be willing to do an experiment with telescopes at Green Bank and a telescope in Moscow, a 22-meter telescope in Moscow. So they sent the letter, and they received nothing back for almost half a year, and they assumed that the experiment simply wasn't going to happen. But then about 5 months later, they did receive a letter from the Soviet Union saying that they were quite happy to agree to the experiment. The reason that they gave for the long delay was that the director of the observatory had been on vacation for 5 months, which the astronomers at NRAO thought was very peculiar. And they also said in the letter, in response to NRAO, that they didn't want to use the 22-meter telescope in Moscow, but rather they should use a 22-meter telescope in Crimea. Now, when I was reading this letter, it struck me as a little weird that they decided to switch telescopes when the 22-meter telescope in Crimea and Moscow are essentially exactly the same, and there's not that big of a difference in the weather. And two, as much as the Soviet Union is a different culture from the United States, I hadn't really heard in my trips to Moscow that 5-month vacations were typical. Otherwise, I would have moved there to do my PhD. And so I was curious to find out what had really happened. And after a bit of digging, I ended up finding a Russian source, which revealed the real reason behind both the delay and the change in telescope. And actually, the delay had been caused by military interference in Moscow, which was really concerned about the idea of doing a VLBI experiment using the 22-meter telescope outside of Moscow, because, as I'm sure many of you know, VLBI, when conducted in reverse, is geodesy, which can be used for really precise mapping. And the reason why they didn't want the US to have an incredibly precise map of Moscow is because they were concerned about the implications that had for bombing, for nuclear bombing. And so that was the main reason why it took so long to respond, and why they ended up eventually proposing to use a different telescope far from their capital. And as it turned out, that same exact conflict ended up happening in the US as well. I found a document at NRAO archives from 1969 where the Department of Defense visited Green Bank and essentially were not sure whether or not they would give permission for this experiment to happen because they were concerned about the impact of geodesy and mapping. They ended up at the end of the day giving permission because they ultimately realized that with the development of aerial photography and satellite imagery, it was essentially going to become a moot point. And Green Bank has a population, I think at the time had a population of 114 people. So it was a little bit less of a concern. So ultimately the experiment did progress. But it's very interesting because it highlights how military and politics could interfere with an otherwise seemingly benign project, right? Looking at really very distant sources such as quasars using VLBI as a technique. The project was riddled. The experiment was riddled with problems like this. For example, it was very difficult to try to bring something called an atomic clock across borders. A lot of Soviet exports officers were very concerned about anything with the word atomic in it. At one point, the experiment was postponed because of the Warsaw Pact invasion of Hungary, which halted US relations with the Soviet Union. At various points throughout the project, intelligence agencies interfered. I've already mentioned the DoD on the side of the United States, but also at one point during the experiment, they had to send magnetic tapes of noise back and forth between Green Bank and Crimea, and one of them disappeared, and it was the suspicion of Kellerman that was actually taken by intelligence agencies because they thought there might be kind of like messages hidden in the noise on the magnetic tapes. Of course, it's impossible to confirm that, but I will say I did a significant chunk of my dissertation on the history of mail interference during this period between the Soviet Union and the US, and it's certainly plausible. So all this is to say that for an allegedly apolitical, purely scientific experiment, this project faced many, many challenges that stemmed from that relationship between radio astronomy and the military. Nevertheless, it did actually end up being a fantastic success. You can see a picture here of the Soviet and American astronomers celebrating with some vodka. This picture of Ken Kellerman using the magnetic tapes on one of the equipments, and that's a picture of the 22-meter telescope in Crimea. And what's interesting is, just again, despite the many, many barriers that the astronomers faced in this project, when Kellerman wrote about the story in The Observer, which I think was about 20 pages of describing the many, many problems they faced, he concluded by saying, more important than the scientific results was the immense satisfaction that all of the participants received from working together to successfully overcome what at times appeared as an insurmountable bureaucratic, technical, and logistical difficulty, and that they believe that in some small way they contributed to an increased understanding between Soviet and American people and demonstrated that scientific cooperation between the US and the USSR was possible. This was a cake that they had at the celebration of the successful detection of fringes from their experiment, and you can see it's got the little telescopes pointing at the quasar, and so yeah, so it was both a success. It was a success in the minds of the astronomers as of science as a tool for diplomacy, and it led to a really long-standing friendly relationship between astronomers in the USSR and later Russia and the United States. Many of the astronomers who were involved in the experiment in the Soviet Union, like Dr. Kardashev and Matvienko, were invited to visit Green Bank on subsequent projects. They eventually, like I mentioned earlier, ended up cooperating on Radio Astron. This is actually a picture that I took in Green Bank in I think 2019 of one of the Green Bank telescopes downlinking with Radio Astron. Back in those days, we actually had quite a number of Russian academics who would come and visit NRAO. Not so anymore. But it did this initial experiment in 1968 fostered an incredibly long cooperative history between NRAO and scientists at Astrospace Center. And so here we have this disconnect, right? The idea of science is apolitical, even when obviously untrue. It's still powerful and it drives cooperation. Historians of science are often used to kind of being buzzkills, because we provide critiques for science, we identify problems, we complicate narratives, and undeniably, here we have a history of the military-industrial complex, of military and politics interfering with science. But at the same time, it's also worth looking at why scientists cooperate with each other beyond the need, for money, military interference, intelligence gathering. And there's something clearly powerful about the scientific myth of internationalism and apolitical science. So the reality is that many of the Soviets that were involved in this international project were Communist Party members. It was very difficult to do international cooperative projects without being tied to the communist government. They certainly were when they visited Green Bank, bringing back intelligence to the Soviet Union. The same happened in NRAO. Ken Kellerman mentioned to me during an oral history interview that he was visited by men from an unnamed government agency who asked him questions about what he saw in the Soviet Union, right? So they were very much participating in spying on each other, on gathering intelligence. But at the same time, again, they really believed that what they were doing was apolitical. They really believed in the power of forming friendships and relationships with these people. When I was in Cambridge, I interviewed another astronomer, Malcolm Longair, who had been part of the early exchange programs between the Soviet Union and the US during the 1960s. And again, I found this same phenomena, which, Malcolm spoke incredibly passionately about the relationships he formed in Russia, about how fascinated he was with the Russian character and Russian culture. He was particularly in love with Russian music. And at the same time, one of the obligations that he had when doing the exchange program was to write a confidential report on everything he saw and experienced there that was then given to British intelligence, right? And so I think that we have not an either or situation, but a this and that situation where it is both true that they were participants in this system of military interference, of science as a tool for intelligence gathering, but also they were forming real friendships, real connections, and fostering communication and dialogue and diplomacy between their respective countries. And so when I talk to scientists about this history, one of the things they want to know is how can we apply the lessons from this history to contemporary situations, right? And one of the things I like to talk about is that it's not so simple as simply just applying the problems or the solutions from the past to the present, but rather examining what tools and systems are at work. So, for example, when Russia invaded Ukraine, the West was certainly right to cut Russia off from scientific research equipment and goods, things like microchips and machinery that could bolster its capacity to conduct war and perform other coercive actions. Solidarity against the invasion of Ukraine is important, and it's valuable to show that solidarity. But at the same time, we need to acknowledge the power of science and science diplomacy as a soft power, right? At the height of the Cold War period, American and Soviet scientists worked together in fields like space exploration, vaccine development, and nuclear fusion, a lot of which helped set the mood for détente, which allowed experiments like the USSR VLBI experiment to happen. So completely severing ties with the Russian scientific community might destroy a channel that could one day aid the peace process. So oftentimes when I'm talking to scientists about how they should go about cooperating with their Russian peers, for example, or other peers in countries which have hostile relations with the US, it's really to look at whether or not their actions stifle the Kremlin's war agendas, if they help Ukraine, and then also what is the impact on humanity or scientific knowledge at large. It's not usually helpful to completely dismiss all scientific cooperation because scientific cooperation, even between states in conflict, can contribute to the development of mutual trust, which we can see through the history of the development of VLBI in the US and USSR. Again, this is known within science diplomacy as soft power. Okay. It's also important to realize that scientific internationalism can fuel dissent within countries. Letters from scientists against the government, as you can see here, can be really powerful tools of soft power, which can destabilize regimes. There's a signature here from a scientist named Yuri Kovalev, who worked with us on Radioastron. He was a postdoc at Green Bank. And we don't necessarily want to burn these bridges. Retaining bridges with Russians who stand against their government helps, again, maintain an effective channel for exerting anti-war pressure. These scientists act in great peril to themselves, and cutting ties with them leaves them in the cold and at the mercy of a regime which seemed increasingly bent on crushing the freedom of inquiry that underpins international scientific work. And so it is, again, important to maintain these channels. And so to conclude, there is this uncomfortable truth that science is both helped and hurt by war. But scientific internationalism, even if it's a myth, which it clearly is, it still has real power, even if just in the minds of scientists. And because of that, it does have the potential to aid international relations. I always tell this to scientists, right, that history rhymes, not repeats. And that's something else important to consider when we're applying this historical knowledge to the present day. The Russian Federation is not the Soviet Union in the 1960s, is not 22. It's important to remember that the VLBI experiment I just retold happened during détente, during a Cold War period, not a hot conflict. And so responses need to be completely different. And I think in the case of Russia and Ukraine, it should be clear that the Ukrainian scientific community needs prioritization, strong support in order to continue its work amidst Russian onslaught. So in some ways, supporting Ukrainian scientists is even more important than maintaining relations with Russian ones. But I think fundamentally, when we're moving forward in contemporary scientific international relations, it's important to remember that cooperation absolutely can happen during times of war and conflict, but it should be done being mindful of the history of the interaction between war and science. And history should be a tool which helps us understand the mentality and the systems and the cultures involved in these histories, but not a playbook from which we directly draw our ideas on how to proceed. And with that, I will conclude.
Just unpinning your video so we can all see everything. Okay. Well, thank you so much for that. We've got a fair bit of time for questions. So if there's questions in the room, questions online. Ramesh?
Yeah, thank you very much. That was very interesting. The history of the 60s and 70s, and I didn't know any of that. But more recently, there has been Radioastron, which you mentioned at the start. So how did all of these issues play out in the context of Radioastron?
Yeah, so that's a great question. So in some sense, we avoided what would have definitely been a sticky situation, because Radioastron actually had a problem with its, I think it was a rubidium clock on the craft. So it was actually decommissioned in 2019, kind of right before all of these more recent conflicts unfolded. And so NRAO currently doesn't have really strong scientific ties to the Russian community. Otherwise, I think it would be, we would have to be looking a lot more seriously at some of these histories and how we've handled these problems. And yeah, I think throughout the history of Radioastron, I really think that the U.S. government has approached it as, again, as a tool of soft power, scientific diplomacy. Radioastron was most largely built, operated, and launched by Russia. Most of the U.S. contribution was just through scientific advisement, and so there wasn't issues of exportation. There weren't issues of sharing computing systems, which I know that can be very challenging. That's something that a lot of scientific institutions are grappling with cooperating with China, for example, now, because the nature of warfare has changed. It's more in the cyber sphere. So it was not as large of an issue with Radioastron as it was in earlier radio astronomy projects.
I have a question.
Yep, go ahead.
Thank you. That was great, Rebecca. I thought that was really interesting. You mentioned some of the agencies that got involved with concerns about exports and use of technology and shared technology. The NSA, I've read in various histories of that agency, one of the most secretive ones, said that their people would come to conferences in radio astronomy, and they felt frustrated because they had to sit on their hands and keep their mouths shut when they knew the answers to questions that the astronomers were asking, technical
Yes.
instrumentation questions, because of the listening telescopes that they were, the listening devices that they've been making.
Yeah.
Do you know, is there anything that's now more that's known about the interaction of, recently I read that they were the NSA was willing to release some of the Hubble equivalents to sell them for cheap to the astronomy community if they wanted them, because they built a bunch of those to look towards the Earth, not towards space. But are there examples of technology transfer from the NSA to the scientific community as they become declassified?
I'm so delighted you asked because yes, I actually know quite a bit about this. So I can't say just in regard to VLBI briefly. I do know that Ken has remarked to me. I should have mentioned I work very closely with Ken Kellerman. He's still at NRAO. He's long retired, but we can't seem to get rid of him. So he's around the building, and I like to ask him a lot of questions from this time. And he's mentioned to me that the meeting with the DoD that happened in 1969 was very peculiar because the astronomers thought they were on the cutting edge developing VLBI as a technique. This was happening kind of competitively in NRAO in Canada and in the Soviet Union. But the members of the DoD kind of seemed like they already knew what they were talking about. So again, they did seem to have development that was already undergoing on their side that had not been shared with the scientific community. But I think even more poignantly, so I've actually done a lot of research into the search for extraterrestrial intelligence, which is a subfield within radio astronomy that also developed in the 1960s and 70s. And it's one of those areas of research which seems very glib and kind of silly, right? Aliens, little green men, but it's actually incredibly situated within the Cold War and again in the military-industrial complex, because what were scientists who were doing SETI trying to accomplish in the 1960s? They were trying to detect artificial signals in space, right? Signs of extraterrestrial intelligence. And they're doing this right at a time in history when there suddenly is a proliferation of intelligent signals in space, right? Through signals intelligence and satellites. And so there was quite a lot of cooperation and information exchange between, believe it or not, NSA scientists and members, radio astronomers who are members of the search for extraterrestrial intelligence. And I know from having done oral history interviews with members of the SETI community who were active at that time, that they would even actually have meetings with NSA scientists where they would essentially exchange technologies. There's actually a case where the NSA, in cooperation with Jodrell Bank, actually conducted a signals intelligence operation to find a Soviet deep space data link that was collecting signals from their Venera probes in Venus, where they actually used a SETI spectral analyzer to detect and find that signal. So there's actually an NSA report detailing how the search for extraterrestrial intelligence aided finding a Soviet deep space data link, because SETI technology was in some ways incredibly important, incredibly useful to NSA agents, because they were developing technologies, again, not only that looked for intelligent signals in space, but often did so by scanning enormous numbers of channels at the same time. So they were really, really efficient. And so, yeah, absolutely that happened. And I would say even in particular in radio astronomy, the naval facility I mentioned, Sugar Grove, that operated within the National Radio Quiet Zone, there's no way of officially knowing this, but the kind of word on the street is that so the Navy left that facility quite a long time ago, and I believe it was believed to have been purchased by the NSA. I believe in 2013. I'd have to check that exact date, but allegedly the NSA owns and operates it now, and so yeah, there's a very strong connection. I could keep going, but I think I've answered your question.
Thank you.
Yeah.
You want to ask an online question?
Yeah, does anybody else have any questions?
Yeah, I have a question.
Yeah, Jonas?
Yeah, thanks.
And then Yulish?
Do you hear me?
Yeah.
Yeah.
Okay, perfect. Yeah, thanks you. So hello from Sweden. It was a really nice talk.
Thank you.
I learned a lot. So I'm wondering if you have done comparisons with other international collaborations during the Cold War. For example, the one thing that pops into my mind is the Antarctic Treaty in the 50s, where there always was a push from the geoscience community to do an international collaboration, but there was also an overlap with military interests in that case.
Yeah, it's a great point. So in my own research, I'm really focused on radio astronomy at the moment. So I haven't expanded outside of that to other areas of scientific cooperation. But I obviously do see the parallels. I think Antarctica is a fantastic example, as is like the Outer Space Treaty, right, with aerospace technologies. So again, I haven't looked into that. If you're curious about the astronomy connection to things like Antarctica, there's a fantastic researcher named Jacob Hock-Misra. So you might want to look into him. I know that he's actually coming out with a book soon that's looking at the history of international treaties from that period, kind of doing a compare contrast between the Outer Space Treaty and Antarctica. And yeah, it's a very interesting and relevant area of research. I'll certainly read his book when it comes out next year.
Thanks. Could you write the name in the chat?
Yes, absolutely.
Yeah.
And I also I can't see how to access the chat. Maybe if I stop sharing my screen, because I'd like to also send you all the VLBI paper. That's the VLBI paper in Jacob Hock-Misra. Okay, they're there. I guess for the people in the room, hopefully you can still access that link. I didn't. It's something like a 25-page essay on the history of the first VLBI event. I was limited by time, but it is not only incredibly fascinating, but also quite hilarious. It's very funny. So if you just want a good, light and enjoyable history of science, primary source reading or secondary source reading, I recommend it.
Thanks a lot.
Hey, great talk and very fun stuff.
Thank you.
I guess you sort of responded to this in bits and pieces, but I still don't have like a full picture of like on the kind of American side of things, how much of information about this first experiment and versus radio astron is still kind of like classified information. Like
yeah.
Yeah.
So
I feel you sort of said a bit about this, but I don't have like the full picture. How much do you think
Sure.
there's still material to sort of uncover?
I would say not a lot, because so NRAO is a government funded facility, but it is not a government facility. It is a civilian organization. We have in-house historical archives, which a lot of my data was gathered from. And a lot of the scientists, again, were individuals, not government employees, who were doing it. And so I have their papers, their diaries, their testimony just firsthand, because I work with them and I know them. What was actually the reason I talk about the classification on the Russian side is because that was a lot more difficult to obtain. I had to rely very strongly on oral history testimony because most of the archives were locked up, and I was not allowed access to them as an American visiting. And it's only gotten harder, actually, unfortunately, because so shortly, the Russian regime is quite repressive to the free exchange of information. When I was shortly after I left, actually, the Putin administration made a law called the Foreign Agent Amendment to the Dumas law, which essentially stated that any individual who receives foreign funding and who publishes information online can be labeled a foreign agent, which can put them under increased scrutiny and interrogation and all sorts of problems. And of course, they were targeting journalists with this act. But of course, I was there funded by the American Institute of Physics, and I publish things all over the place because I'm a historian. And so if I were to return to Russia, I would be a foreign agent. So that would make me even have less access. There's no way I probably would have access to the Russian Space Research Institute that I did have in 2019. And so, and of course, I have spoken out publicly here, this is going on YouTube, against the Russian invasion of Ukraine. I have dared call it a war, which also means that under the more recent Dumas law, I could be arrested. And so I don't want to make it seem like the US is a lovely, perfect place that doesn't have the military or government interference. It absolutely does. But I am an American citizen. I have access to these institutions. I have access to these people. And of course, we're not actively trying to suppress well, maybe we are in some ways, but there is available information on radio astronomy in US facilities to American citizens. And so it's very challenging to get that information on the Russian Soviet side, which is why, again, there's more oral history information that I have to rely on there than documentary.
Sorry, thank you. That clarifies
Okay.
things beautifully. But do you just one quick follow up? Do you think it's similar with Radio Astron, that the sort of information on the kind of American side of things is sort of relatively easily available?
So yes and no. So Radio Astron was mostly planned. I mean, it's been being planned, I think, since the late 70s or early 80s. And it launched in 2011. And so this is kind of before the increasing tensions. This was kind of right around the time the Soviet Union fell. So there was a lot more, there was glasnost, right? A lot more free information. So we actually have in NRA archives a ridiculous amount of paper of primary source material from Radio Astron. That's probably gonna be one of my next projects, is focusing really strongly on Radio Astron. And it's so it's not as big of a problem. Again, on the US side, we do have Russian documentation just because there were meetings held, right, to risk the Radio Astron International Scientific Council meetings. But again, on the Russian side, it is trickier because they tend to be a little bit cheekier with using labeling scientific instruments. Labeling military instruments as scientific instruments. Predating Radio Astron, the Russians launched another satellite that they called KRT-10, which was supposed to be the first space interferometer. However, if one tries to go into the Russian literature and look for any VLBI published articles using KRT-10, you will find nothing. You'll only find Pravda newspapers saying, look at this VLBI telescope that seemingly weirdly is never used for VLBI in the scientific literature. And I found out by talking to some of the people who actually helped launch it, it was not a VLBI telescope. It was an intelligence gathering telescope, right? So they just tend to be a little bit, they have a greater overlap between their military and scientific infrastructure, where the US at least pretends to have this civilian military distinction, which of course we all know doesn't really work out perfectly in practice, but there is at least that mythic line, which I think makes doing the historical research a little easier. I hope that answers your question. Cool.
Well, we have about 5 minutes left, so if there's any further questions, but if not, we can finish a couple of minutes early and head into reorganize the room for colloquium, which comes up next.
Great.
Okay, well, thank you so much for your talk.
Great.
This has been really interesting. And I don't know if you know about the Next Generation Event Horizon Telescope HPC group, but if that's something of interest to you, we would love to have you come join us.
Yeah, I'd love that. Yeah, please email me.
Yeah, I will.
Wonderful. Yeah, thank you for inviting me. I had a lot of fun.
Yeah, thanks so much for talking to us. It was a really fascinating history.
Oh, good.
Yeah, so I'll take it back again.
Thank you.
Bye.